Hey YouTube, it's Justin the Junkie. How the fuck are you guys doing today?
Loogies when I puff on it. I got some bucks on it, but it ain't enough on it. Go get the S, the T-I-D-E-S. Nevertheless, I'm hella fresh, rolling joints like a cigarette. So pass it across the table like ping pong.
So today, we are taking major steps. You probably have heard me talk about building these custom socket trays. So what we have here is we have an aluminum plate that I'm going to mount to this table. Okay, now why I'm doing it like that is so I can make, like, the 3/8 sockets rails are going to be 24 inches long, okay? But they're going to hold all your sockets, and they're going to be about 6 inches wide. So what I'm doing is I'm making this plate so we can have a fixturing plate to mount there. Now how I'm going to mount this is we're going to face this, we're going to run the edges right now, then we're going to face it just to try to get this perfectly flat right here. And we are going to be doing some indicating and stuff like that to the best of my ability. I'm not going to say that this is going to be 100% perfect, but I am going to try to make it as close as I possibly can. Now, I already, did the other side. So I did the 3 corners. Now all I have to do is this side, so I thought I'd bring you guys along at this step once I kind of got it figured out. But this is going to be a long, drawn-out series. I know that people are probably not going to like it, but what I'm trying to show you is how things are manufactured in this country, or in any country, really, that somebody has to spend the time to build the jig, to build this, to build that, before you sell something, and all this stuff has to be figured into the price of something and all that stuff. So, luckily, a Patreon donated this plate. He keeps donating to this project, and I'm going to tell you, I probably couldn't do it without him. No, I'm going to say that. I couldn't do that without him. He knows who he is. He chooses to stay anonymous. He has given a lot of stuff to this channel, and he probably will continue to do that in the future. You know, he wants to, I think he wants to buy a milling machine, but his wife would probably kill him. But my wife is ready to kill me now too. But anyway, that's for a different story. We'll explain that in a future upcoming video about this. So what we're going to do is I'm going to bring you in. I'm going to show you how I have this indicated in here. And I have it up on these huge parallels just so, we know we got it flat and all that type of stuff. And we are going to buzz the sides off. And then what we are going to do is face the top of it. Now, with this milling machine, I can only make about a 24.5-inch run at one time. So I have to constantly move it, then recheck and all that stuff. It takes a considerable amount of time to do this, to set up this jig. But once I get this jig set up, we're going to be good. So this is step 1 of building socket trays. I don't know how many videos this is going to be, but stay tuned, and hopefully by the end of this series we have a socket tray that you, me, everybody can be proud of, and I show you the whole process of how it's done. So let's get moved right in here, and I'll show you how I have it indicated. I don't know if this is the best way, but for my skill level where I'm at, I thought this would work, and it has been working. So let's get right into this. Alrighty, so what I have is I have it up on these parallels like I said before, and I have this indicator just in my drill chuck. It's a Starrett back plunge indicator, and what we are trying to do is we are making sure that this piece is sitting in there. Well, think about it sitting in there like this. We don't want it cocked off to one side. We want it to be as flat as we possibly can start. Now, for this type of operation, I'm okay with 1 to 2 thou. I don't think that's really going to hurt me. I'll just make sure that I match it up when I have to move this. So as you can see, we'll watch the indicator here. And I'm just running the power feeds on the table. It's a lot easier to do that than crank by hand, let me tell you. But I'm trying to get this in there square and flat, okay? So you can see that we're pretty close to 0. It took me about 10 minutes to get it like this. I get it pretty close by eye and then just tap it on there, you know, and you can see that we got about 2 thousandths worth of run out, maybe a little bit more. I don't really like that. So we got 2 thousandths worth of run out there. So what we're gonna do is just, oh, wrong way. Tap it back just a little bit, there we go. And then we'll just check it again back here, and we should be good, and then we'll get the cutters in there and start ready to cutting. I gotta get my safety glasses before we do that. And now we're about 2 thou the other way. So we'll let it run all the way till it stops, and then we'll tap it over just a little bit, and we should be ready to start cutting. Or if it ends up 0, it ends up 0. Okay, we'll just check it one more time because we are going to start down here on this end. All right. Whoa! Whoa! Wrenches falling off the rack. Why machining takes so long is 90% of it's in the setup. If you get the setup right, you will be amazed of how good your parts will turn out. So as you can see, there's 0. We're going to run off to the end of the table. We're going to turn that off. Now we're going to take the drill chuck out. First of all, we're going to open this back up, pull this up, take this out. There's our indicator out. And all that stuff. All right. So now, right there, we're about ready to start cutting. So the next thing, I'll kind of show you what we got to do here. So what we got here is I got a 3/4 inch end mill. That's the only kind of 2-fluter finish cut end mill that I like running about a 3/4 size for some reason. I don't fucking know why. So what we want to do is crank this over. All right, now we're just going to touch off on our part. Right about there. We're going to re-zero the indicator. Come down. Now, we don't need, this WD-40 works great. Now, we're not trying to take this to any certain diameter, so what we're going to do is we're going to dial in 25 thousandths. All right, we got 25 dialed in there. Now what we're going to do is just turn the mill on and get out of the way, and we are facing this off. Let me see what we got here. Oh. Not deep enough. Let me back it up. I gotta come down on the quill just a little bit, but you don't want to do it in there because we got a huge burr down here. Alright, so let's come down on the quill just a little bit more. There we go. Turn that back on. Yeah, now we're not leaving that burr down there. So we're only gonna take about 25 thousandths off this. This particular item right here. And you just want to have, and then what we'll do, this WD-40 works good. You can see where we stopped there. We got to get that out of there. So 25 thousandths is pretty good. So we're just facing this off. But it's not leaving real bad shatter marks, so I'm okay with it. Alright, then we'll just run it backwards. And we are going to put a step in this right here, but when we move the part, we'll fix it. I'm not going to come in another 5 thousandths just to fix this. WD-40 works really good on aluminum. Okay, so we're gonna unlock the table. I'm gonna come in another. This is gonna come in 5 thou, maybe 6. All right, then we'll just cut this off, face this. Chips. That's what I hate about this stuff. Got a real nice finish here. Chips aren't real hot, so we're doing pretty good. So there's that. Then we will just fix this on the back thing. Now what we have to decide to do is if we're going to move this down this way, which I think that's what I'm going to do, and then we will re-indicate it, and we will get this on there. Then what we will do is, that's just facing the sides. You guys get the idea of that. I'll move it again and put some clips into there. We'll get that done. And then I think maybe the best way to do the face this would be to drill the holes right here. But see, then we're not going to have flat surfaces. Okay, let me think about this here for a little bit. I'll be back. Alrighty, we're about finished with this. I got it moved, and you guys understand how that does. So once we get done with this, we will have all the sides faced. Then we have to decide what we're going to do. Either drill holes in this, or how we're going to face this to get these surfaces flat. Which I'm thinking about drilling holes first and going from there. So that's pretty good. We got a little step in it, but again, this dimension is not critical. So now that we got this all finished, all 4 sides are even, square, or we got it faced. Now what we're going to do is we're going to take all this stuff off, move the table around, and then we got to drill 3 holes in here because I'm going to hold it on the outside. And I'm hoping that gets me good enough. What I'm going to do is split the difference of how wide this is and have it down in there under the holes, and then we will have it slid down here, clamped in, drill some holes, and we should be good. Alrighty, so what we're doing is we got our edge finder here, and the reason I'm getting that out is that we need to figure out which is exactly 1 inch over. Now I have the Y spacing fine because I just slid the part down and just indicated it in, and we know that we're good there. So what I have to do here is turn this on, okay? And what we're going to do is, you can see that this is wobbling how you use that, okay? Now what we have to do is come in till this touches our part, and you're going to see it's kind of going to true up, and then as soon as it kicks off just like that, we are going to re-zero the DRO, Okay, now what I will do is I'll let you guys look at the DRO. Now what I'm going to do is that I have to come 100,000 back in, okay? And that's half the distance of this tool, or you know, the edge finder. It's 200 thousandths around, so to find the true center, we have to have 100,000. Oh, 998, that's not good. Jesus. Okay. So, as you can see there, we are going to re-zero this, okay? Now what we're going to do, just to verify that we're down, I just like to come down and you can see that we're kind of, you know, halfway in the hole there or whatever, but I know from experience messing with this that that's what we got. So, you know, this is my, this is a Michitoya, I do believe, right here, but it's just an edge finder to find your edge. So now what we're going to do is that I know I got to come in 1 inch, okay? And I'm going to come in 1 inch. That's where I want my pieces to go. Okay, so I'm going to come in 1 inch. Okay, and what we're going to do is, Jesus. Okay, now we know if we drill right here, we are 1 inch in and 2 inches off this side. Okay, so we know that we got that right there. So what we're going to do is just make sure that we're 2 inches right here. Lock that part of the table in. Now we moved a little bit on our x-axis, so we're going to dial that back in. Okay, so we got that. Now what we're going to do is we're going to center drill these. All right, move the table up a little bit just so we got the center drill closer, and then we will drop the table back down. Right here we are going to center drill this. Now I like this WD-40. We're going to turn this on. We're going to come over here and just center drill. Okay, now what we're going to do is, okay, you can see that the DRO reads 1 inch in and our y-axis is 2 inches. That's where our first hole is. Now what we have to do is I know the second one is at 4.5 inches. So I'm going to come over to 4.5 inches and we are going to drill another hole, or another center hole, if I can get to 4.5 inches. There's that, just a little squirt of WD-40. All right, there's 4.5 inches. Now, we can know that our next dimension is 7 inches. So we'll dial in to 7 inches. Okay, there's 7 inches. Again, center drill this. Okay. Now we have that center drilled. All righty, we don't need to do anything more there. And what I like to do is I just get my scale out here, and we are close to dead on the money right there. So now what we have to do is drop the table down. Now what we're doing is we're not going to move anything. We're not going to move anything there. I just relocked the table and moved it 0.2 of an inch. But anyway, you know, WD-40 everything. Come down. Now we're drilling this 17-30 seconds, okay? And I'm going to explain to you why I'm drilling this 17-30 seconds here in a little bit in the next feature. This aluminum gets gummy. Okay, as you can tell, we went right through the center of our ways. Okay, now we're going to move to a 450. Got a hand crank, motherfuck. Which 4 inches and a half is 4 and 500 thousandths, if you get what I'm saying. I mean, I'm sure if you guys know about machining, you know, where, you know what, 400, half inch is 405 thousandths. All right, now we're gonna re-drill this hole. Got to do the peck drilling method here. WD-40 that. All right, again, didn't hit the ways, so we know we're good. Let me get a brush or something here. We gotta get a chip brush to control all these chips. They go fucking everywhere. Now all we gotta do is roll back in the 2-inch and drill our hole. Now you're probably wondering why I got these Mighty Bite stops on there. What I'm using them for is to keep this square and to keep this plane square and use it as like a stop, so I knew where to come over to. So we just keep drilling. You know, now what I think is that, all right, now this is just me thinking here, but, you know, I think that these 6 holders are going to hold down this stuff, and you can see we got a pretty big chunk out of it right there. This aluminum plate, this aluminum is pretty soft. Now, what we're going to do is take this drill bit out. Now, the reason that we did 17/64 is because this diameter is 529, and you can see that this fits in there perfectly good. Alrighty, and then what we're going to do is use the quill because I have a what do you call that? A readout on the quill. I'm going to come down and I'm going to check. Okay, we're a little off on 0. We want to re-zero that. Okay, now I know that we re-zeroed that. What I want to do is I want to bring this down 635 thousandths. So this is just a counter bore for socket head cap screws. So we're basically bringing it down 650 thousandths, which is, you know, whatever. There's 650 right there. All right. Now the chips didn't get us stuck on there. Okay. Then we'll just repeat the process. 4.5 inches. And we can check. Now this dimension does not have to be critical. I mean, it's just a clearance hole to put our socket head cap screws down. And when we face like 10 thousandths off this thing, or 10 or 15 thousandths, we're going to be good. So there's that. Now we'll come over to 7 inches and repeat that process. I mean, it's a lot of just moving and all that stuff. I will tell you that I did the other side and I used the DRO, and this has been about some of the best holes I've ever drilled in my entire life. I like the WD-40. It's a lot better than the cutting oil. It's not getting gummed up as bad. Just for future reference. And I'll show you what we're going to use WD-40 for. A friend of mine gave me a helpful tip and on what the WD-40 is good for. But now you can see we got all that done. We got our counterboards done. Throw all these chips around. Now we're ready, you know, to go ahead and face this. And I think what I'll do is I'll show you guys kind of how I'm going to face this in this video. And then in the next video, we're going to come, you know, we'll be ready to start building our prototype, which I'm going to use out of foam. So give me a minute to get all this shit cleaned up. As you can see, there's shit everywhere. I want to get organized. Come down here, make sure everything fits. I will show you that. Get it all cleaned up, and we are going to start facing this plate off. And I have to do it as a technique. My face mill is 3 inches, so I have to square everything up. That's what this clearance hole's for. I can fudge it just a little bit. We will do that and come back. We got the face mill on there. We're gonna run this not that fast. We're gonna run it about 10 inches a minute. I got the thing turning 1800 RPM. What we're gonna try to do, attempt to do here is face this smooth. So I sprayed it down with WD-40. Let's see what we got. Now this is absolutely going to throw shit fucking everywhere. Let's see if I can get that on there. So we're only facing about 15 thousandths off of it. And we're just going to run across till it gets done with that. Damn it, it's not high enough. Oh shit. See if I can create a... That one's not low. Son of a bitch. Well, we're going to have chips fucking everywhere. But anyway, you can see here that we got it faced off. And I'm just going to run across here. And I'm going to be using this thing to actually have a little more speed there, since we're not taking very much. The mill's trammed in pretty good. Okay, run that back across there. Let me see if I can blow this off just a little bit so we get all these, we don't have these chips sitting there. So that's what we're going to do to face it. Then I'm going to slide the plate down. You guys don't need to see all this facing stuff. You saw one of them. You've seen one, you've seen them all. It won't be too bad. I'll go ahead and move this down, and then we will do whatever here. I'll move this down once this comes back, and we'll move over 3 inches and start again. Here we go. We got the tooling plate mounted, and on the table here, I got it mounted with 3 socket head cap screws in the T-nuts down in the bottom. I don't think I need to put any in the middle. This thing sounds pretty rigid, or feels pretty rigid in there. But if you want to, we can scroll it across and kind of see how flat we are here. You know, I got a couple little beginner marks over here in the table, but other than that, we're about half or a thou off right there. Two thou in the middle. That's what I'm afraid of. If I pull it down in the middle, it'll get worse. Now it's coming back. The problem is I can only make 24.5-inch runs, like I talked about earlier, and the table is 42 inches wide. So You know, there's going to be a little bit of inconsistency in there, but you can see we're about 1.5 thou off over 42 inches. We're also, you know, like I don't have an indicator to put right in there, but thought I'd show you. That's it for this part. The next part, we're going to come in and we're going to try to figure out how to make our mountings, because I got some Mighty Bite holders that I want to put in there, and we'll pick a side that we're going to work off of, and that's going to be the side. I think I'm going to work off the front. To be honest with you, I want to check some stuff on the front first, but to see what our run out is over here. I guess I could do that, but I got a little stupid idiot mark there. But other than that, looks pretty good. Like always, you know, until next time in this series, this is the first thing we had to build so we can make, you know, runs and have this stuff mounted down to the table and all that shit. So guys, I hope you enjoyed the first part of this video series here. You know, it's going to be, I don't know how many series this is going to be. I can't give you a number. I don't know. Could be 4, could be 5, could be 6. I don't know, but we're working towards it. This was the biggest step, was getting a tooling plate made. I think everything else will be pretty easy. I'm understanding the DRO a lot better and all that shit. So we're looking good there. Like always, check out the Patreon account. Check out onlinetoolvendors.com. Check out Facebook, Instagram. Instagram, I've been hitting hard again lately, so if you guys want to follow me on there, follow me on there. But like always, thanks for watching, and I gotta fucking go.